We know more about space than we do about the ocean, which is true. I took a big breath and went down. Right in front of me there was this huge eyeball. Those underwater listening devices were most likely so they could hear UFOs moving around. The Pacific Northwest is a region long associated with natural beauty and geological mysteries. Towering mountains, deep forests, and breathtaking coastlines dominate the landscape. Beneath this serene exterior lies one of the most geologically active regions on Earth. Mount St. Helens, a name synonymous with catastrophe following its infamous 1980 eruption, has remained a focal point for scientific study for decades. Recent discoveries made by the U.S. Geological Survey (USGS) have uncovered something new and deeply unsettling. A leak has been found in the ocean floor near Mount St. Helens. The implications of this discovery are both shocking and terrifying. This is not merely a geological curiosity. It could have far-reaching consequences for the region, the planet, and the delicate balance of ecosystems that call the Pacific Ocean home. What lies beneath this leak, and why are scientists so concerned about its presence? Let's dive deep into the chain of events leading to this discovery, the nature of the leak itself, and what it means for humanity's understanding of the forces shaping our planet. Mount St. Helens has always been a geologist's enigma. Even before its cataclysmic eruption in 1980, the volcano was closely monitored due to its volatile history and location along the Cascadia subduction zone. This subduction zone, where the Juan de Fuca plate plunges beneath the North American plate, is one of the most tectonically active regions in the world, a place where earthquakes, volcanic activity, and deep geological shifts converge. In recent years, researchers have been using advanced tools to monitor seismic and geothermal activity around Mount St. Helens, as well as its neighboring volcanoes in the Cascade Range. While the mountain itself has shown signs of reawakening, it is the surrounding ocean floor that has now stolen the spotlight. What was supposed to be routine underwater geological mapping turned into a discovery that stunned the scientific community. The leak in question was first identified through anomalies detected in thermal imaging scans of the ocean floor. These scans revealed a patch of seabed releasing warm fluid at an alarming rate. Initially, scientists assumed this was another hydrothermal vent, a common feature near tectonic boundaries. But further investigation revealed that this wasn't an ordinary vent. The fluid escaping from the leak wasn't just water heated by the Earth's mantle. It contained high levels of methane, carbon dioxide, and other gases typically associated with volcanic activity. More importantly, it was laced with chemical compounds that suggested a direct connection to magma reservoirs deep beneath Mount St. Helens. This connection raised immediate red flags for geologists. A leak of this nature indicates that the magma chambers feeding Mount St. Helens could be under extreme pressure. Such leaks act like pressure release valves, and while they might temporarily alleviate some stress, they also signal instability in the system. If the pressure builds beyond a critical point, it could lead to significant seismic activity or even another eruption. But there's more. The location of the leak is particularly alarming. It sits not far from the Cascadia subduction zone, a region notorious for its potential to unleash megathrust earthquakes. These earthquakes, capable of reaching magnitudes of 9.0 or higher, are among the most powerful and destructive natural events on Earth. A destabilized magma chamber in this region could potentially trigger seismic activity along the fault line, creating a chain reaction of catastrophic events. Adding to the complexity is the chemical composition of the fluid being released. The methane and carbon dioxide escaping from the leak are potent greenhouse gases. While the quantities being released are currently small compared to global emissions, the leak's existence raises concerns about the potential for more widespread releases in the future. Methane is over 80 times more effective at trapping heat in the atmosphere than carbon dioxide over a 20-year period. A large-scale release of methane from beneath the ocean floor could accelerate climate change in ways we are not prepared for. Scientists are now scrambling to assess whether this leak is an isolated phenomenon or part of a larger network of leaks hidden beneath the ocean floor. To understand the gravity of this discovery, we must consider the history of methane hydrate destabilization. Methane hydrates are crystalline structures that trap methane within ice, commonly found beneath the seafloor in regions like the Cascadia subduction zone. These hydrates are stable under specific pressure and temperature conditions, but even small changes can cause them to destabilize, releasing vast amounts of methane. The leak near Mount St. Helens appears to be tapping into one of these reservoirs. If the surrounding environment continues to warm, either due to geothermal activity or climate change, it could set off a domino effect, destabilizing more methane hydrates and creating a feedback loop of warming and methane release. While the environmental implications are staggering, the geological risks are equally dire. The connection between the ocean floor leak and Mount St. Helens suggests that magma from deep within the Earth is migrating in unexpected ways. This migration could lead to increased volcanic activity, not just at Mount St. Helens but potentially at other volcanoes along the Cascade Range. Volcanologists have long feared the possibility of a chain reaction in the Cascades, where the eruption of one volcano triggers activity in others. Such a scenario could have devastating consequences for the millions of people living in the Pacific Northwest. Cities like Portland, Seattle, and Vancouver are all within range of the fallout from multiple eruptions. The USGS has been quick to downplay immediate concerns, emphasizing that more research is needed to understand the full implications of the leak. But behind closed doors, the sense of urgency is palpable. Emergency response teams are reviewing evacuation plans, while geologists work around the clock to monitor seismic activity in the region. One of the most pressing questions is whether this leak could be a precursor to a major eruption at Mount St. Helens. The mountain has erupted many times in its history, but the 1980 eruption stands out as a stark reminder of its destructive potential. That eruption obliterated 230 square miles of forest, killed 57 people, and sent ash plumes circling the globe. If a similar event were to occur today, the impact could be even more devastating due to the region's increased population and infrastructure. But Mount St. Helens isn't the only concern. The Cascadia subduction zone's potential for a megathrust earthquake remains one of the most significant geological risks in North America. Such an earthquake would not only cause widespread destruction on land but could also generate massive tsunamis, inundating coastal communities and causing billions of dollars in damage. The discovery of the ocean floor leak has added another layer of complexity to an already precarious situation. Scientists are now questioning whether the leak could serve as a trigger for seismic activity along the fault line. If so, it could accelerate the timeline for the next Cascadia megathrust earthquake, which many experts believe is already overdue. Meanwhile, researchers are deploying advanced robotics and deep-sea submersibles to study the leak up close. These technologies allow scientists to collect samples, map the seafloor, and monitor changes in real time. Preliminary findings suggest that the leak is growing both in size and intensity. This escalation has raised concerns that the underlying magma chamber is becoming increasingly unstable. The implications of this discovery extend far beyond the Pacific Northwest. If the leak near Mount St. Helens is part of a larger pattern, it could signal a new phase of geological activity on Earth. As tectonic plates continue to shift and climate change accelerates, we may see more of these leaks appearing in other tectonically active regions around the world. The interconnected nature of Earth systems means that a disturbance in one area can have ripple effects across the globe. For example, increased volcanic activity in the Cascades could release aerosols into the atmosphere, temporarily cooling the planet but also disrupting weather patterns and agriculture. Similarly, a large-scale methane release could accelerate global warming, leading to more extreme weather events and rising sea levels. As humanity grapples with these challenges, the discovery of the leak serves as a stark reminder of our planet's power and unpredictability. It underscores the importance of investing in scientific research, disaster preparedness, and global cooperation to address the risks posed by natural phenomena. But it also raises deeper questions about our relationship with the Earth. Are we merely spectators in a geological drama that has been unfolding for billions of years? Or do we have a responsibility to mitigate the impacts of these events? Can we harness our technological capabilities to adapt to a changing planet, or will we become victims of forces beyond our control? For now, the leak near Mount St. Helens remains a mystery, one that scientists are racing to unravel. As they delve deeper into the ocean floor and the Earth's crust, they are uncovering not just answers but new questions that challenge our understanding of the planet we call home. This discovery is a wake-up call, a reminder that the Earth is alive and constantly changing. It is a call to action for scientists, policymakers, and ordinary citizens to work together in the face of uncertainty. Because in the end, the greatest threat is not the unknown, it is our ability to prepare for it. As scientists push forward with their investigations into the leak near Mount St. Helens, a number of critical revelations have come to light. These revelations are deepening the mystery surrounding this discovery and raising alarms within the scientific community. While much of the initial attention focused on the potential geological risks, the leak itself is now being studied as a unique phenomenon with implications far beyond what anyone originally anticipated. One of the most pressing concerns is the scope and scale of the leak. It's no longer being classified as a single isolated occurrence. Data collected from deep-sea monitoring equipment has revealed a network of fissures and smaller leaks extending outward from the main site. These fissures stretch over an area of several square kilometers, creating what researchers are now calling a submarine geothermal system. The system is not only venting gases like methane and carbon dioxide but also releasing vast amounts of superheated water laced with trace metals and other substances from deep within the Earth's crust. This finding has set off a chain of investigations into how these materials are affecting the surrounding ocean. Preliminary studies have shown a sharp increase in localized ocean temperatures and changes to the water's chemistry. Marine life near the leak site is behaving strangely, with many species abandoning the area entirely, while others seem inexplicably drawn to it. This shift in behavior could be the result of toxic compounds entering the water or other unknown environmental changes triggered by the leak. Perhaps the most surprising finding so far is the presence of certain isotopes in the leaked materials. These isotopes, rarely found near Earth's surface, are believed to originate from deep within the planet's mantle. Their presence suggests that the leak is tapping into geological layers far deeper than initially suspected. This raises a troubling question. How deep does this system go, and what else might be lurking beneath the Earth's crust, waiting to be unleashed? The deeper the scientists dig, both figuratively and literally, the more it becomes clear that this is no ordinary geothermal event. The interconnected nature of the fissures and the strange isotopic signatures hint at an underlying cause far more complex than the typical volcanic activity associated with Mount St. Helens. Some researchers have even begun speculating that the leak could be connected to long-dormant geological structures that predate the current tectonic configuration of the Pacific Northwest. Adding to the intrigue is the discovery of seismic tremors in the vicinity of the leak. These tremors, known as harmonic tremors, are often associated with the movement of magma and are a hallmark of volcanic activity. However, the pattern and frequency of these tremors are unlike anything previously recorded in the region. This has led some experts to hypothesize that the leak may be part of a larger, still unfolding geological event, one that could culminate in significant changes to the region's landscape. The potential for an underwater volcanic eruption is now being seriously considered. While most people associate volcanic eruptions with dramatic explosions and fiery lava flows, underwater eruptions can be equally, if not more, devastating. The immense pressure of the ocean can contain the initial blast, but the sudden release of gases and heat can trigger tsunamis, destroy marine ecosystems, and send shockwaves through the Earth's crust. If such an eruption were to occur near Mount St. Helens, the consequences could be catastrophic. A massive displacement of water could generate a tsunami capable of reaching coastal cities within hours, leaving little time for evacuation. The economic and environmental toll would be staggering, with billions of dollars in damage and countless lives at risk. As scientists grapple with these worst-case scenarios, they are also exploring how the leak fits into the broader context of Earth's geological processes. Some have suggested that the leak could be part of a super plume system, a vast column of hot rock rising from deep within the Earth's mantle. These super plumes are thought to drive major geological events, including the formation of volcanic hotspots and the breakup of continents. If the leak is indeed connected to a super plume, it could represent one of the most significant geological discoveries of the century. However, this theory comes with its own set of alarming implications. Super plumes are incredibly powerful and unpredictable, capable of reshaping entire regions over geological timescales. If Mount St. Helens and the surrounding area are sitting atop such a feature, the region's future could be far more volatile than previously imagined. The environmental implications of the leak are also becoming a focal point for research. The release of methane and other greenhouse gases is already contributing to localized warming, but the long-term effects could be even more severe. If the leak continues to grow or if additional leaks are discovered, it could accelerate the destabilization of methane hydrates across the region. This would create a feedback loop of warming and gas release, further exacerbating climate change on a global scale. But the story doesn't end there. The changes to the ocean's chemistry are raising concerns about the potential for mass die-offs of marine life. Many species rely on stable environmental conditions to survive, and even small changes in temperature or chemical composition can have devastating effects. If the leak disrupts these conditions on a large scale, it could trigger a cascade of ecological consequences, from the collapse of local fisheries to the extinction of vulnerable species. Meanwhile, the leak's discovery has sparked a flurry of international attention. Geological surveys and research institutions from around the world are collaborating to study the site, sharing data and resources in an effort to better understand the phenomenon. This collaboration has led to some unexpected insights, including the realization that similar leaks may exist in other tectonically active regions but have gone undetected due to a lack of monitoring. The technology being used to study the leak is also pushing the boundaries of what's possible in underwater research. Autonomous underwater vehicles (AUVs), equipped with advanced sensors are mapping the seafloor in unprecedented detail, while remotely operated vehicles (ROVs) are collecting samples and capturing high-resolution imagery of the leak site. These tools are providing a wealth of data that could revolutionize our understanding of underwater geological processes. Despite these advances, many questions remain unanswered. What caused the leak to form in the first place? Is it a symptom of broader geological instability in the region or an isolated anomaly? And perhaps most importantly, what can be done to mitigate its impact? One potential solution being explored is the use of containment technology to capture the gases being released from the leak. This would not only reduce the environmental impact but also provide valuable data on the composition of the materials being emitted. However, implementing such a solution would be a massive logistical challenge, requiring extensive resources and coordination. Another avenue of research is focused on predicting future activity in the region. By analyzing the patterns of seismic activity, gas release, and other indicators, scientists hope to develop models that can forecast when and where additional leaks or eruptions might occur. This would allow for more effective planning and preparedness, potentially saving lives and reducing damage. But even as researchers work to address these challenges, the leak serves as a sobering reminder of the limits of human knowledge and control. The Earth is a dynamic and ever-changing system, governed by forces far beyond our ability to fully comprehend or predict. While we may strive to understand and mitigate these forces, we must also acknowledge our vulnerability in the face of nature's power. The discovery near Mount St. Helens is a wake-up call, a reminder that we live on a planet that is both beautiful and unpredictable. It challenges us to think more deeply about our relationship with the Earth, our responsibility to protect it, and our place within its complex and interconnected systems. As new findings emerge and the story continues to unfold, one thing is certain: the leak near Mount St. Helens is not just a geological curiosity. It is a window into the hidden forces shaping our world, a mystery that demands our attention, and a call to action for scientists, policymakers, and citizens alike. The road ahead will not be easy. There will be setbacks, uncertainties, and moments of fear. But there will also be opportunities for discovery, innovation, and collaboration. By working together and embracing the challenges before us, we can turn this moment of crisis into a moment of growth, a chance to better understand our planet and our place within it. And so, as the investigation into the leak continues, we are left with a choice: to look away and hope for the best, or to face the unknown with courage and determination. For in the end, it is not the leak itself that defines this moment but how we choose to respond to it.